Okay, so we're going to start looking at what's known as hypothesis testing. So in chapter 10, we did confidence intervals. So confidence intervals, we looked at both directions and we were trying to determine where we think the values would fall. And hypothesis testing, we're going to have basically do that. We're going to do the exact same thing. Sometimes we're only going to go look one direction, but we're going to have what we believe to be true first. We're going to say, we believe this to be true. And then we're going to, after we get our answer goes, well, it's in that spot, so yes, it's true. Or it's outside the spot, so no, it's not true. That's what we're going to look at. So that's the extra piece that we're going to be adding. We're going to determine if what I believe to happen is actually going to be true or not. Everything up to that point is no different than we just did for confidence intervals. Okay, so if you were struggling in chapter 10, you didn't really get confidence intervals very well, we're going to redo the exact same thing basically, and then we're adding one little test step at the very end. Okay, so it's really not drastically different from what we're doing. We're only going to look at the population mean today. On Wednesday, we'll do the proportions. So we'll do the means today and the p-hats on Wednesday. But again, the concepts are the same, just a couple of calculations are different. All right. If you've ever taken a science class, this should not be any different from that. Hypothesis is a statement or a claim about a characteristic of one or more populations. So it is what you're claiming to be true. Okay. And then the hypothesis test is the procedure we're going to use to test if that claim is true or not. The difference in your science class, you typically would have to do experiments and stuff like that to get it. In the statistics class, you collect data to do that. How you could do that through surveys or whatever else. You collect a random sample and you get it. In this, what we're going to do is I'm just going to give you a bunch of problems that are going to have all that done for you, and you're just going to have to determine if their claim is true or not. This is probably the most important part, and this is what you're going to. This is what is either going to be very nice for you on section 11.1 or kill you on section 11.1. You have two hypotheses that we're going to state. You have your null hypothesis, which is what you assume to be true. Okay, so we have our null hypothesis. This is what we assume to be true. Your null hypothesis will be designated as that H naught, so the HO. And it will always be equal to. Okay, so your null hypothesis is the HO, and it will always be equal to. Your alternate hypothesis is H with the little a. This is looking at the directions that we have. So this one's either going to be less than, greater than, or not equal to. And that depends on my direction that we're looking at. Okay, so your null hypothesis will always be your equals, and your alternate hypothesis is going to tell us the direction we're going to be looking. So if it's less than or greater than, these are what's known as my one tail. And that is my two tail. So if we're looking less than or greater than, we're only looking one direction. So that's a one tail test. This will all make more sense in a minute when we look at it. The not equal to means we're going both directions. The not equal to is exactly what your confidence interval was. You're looking both directions. Okay? The not equal to is no different than chapter 10. The one-tailed, we're only looking one direction. It is slightly different. But that's where that T-table chart that I gave you on last week is going to come in handy. So everybody take out this table because you're all going to need it. Yes.
Do you have another copy?
Yep. And a few extras. Sure. You're welcome. All right. Let's look at the new thing, and then we'll go and add it on to the rest of the stuff that we did. Let's look at identifying the null hypothesis and the alternate hypothesis. All right, so potato chip manufacturer is concerned with the bagging equipment is not functioning properly when filling a 10-ounce bag. Everybody would agree with this. So he wants to test a hypothesis that'll help determine the problem with the bagging equipment. What's the correct hypothesis? So the null hypothesis here, the null, equals 10 ounces. Okay, that is my null hypothesis. It is the exact statement of what they're making. It's supposed to have 10 ounces in it. So that's my null hypothesis. Okay. My alternate hypothesis is what is happening. So he says he wants to test the hypothesis to determine if there's a problem with the bagging equipment. If there's a problem, what would that mean? It's not equal to. It's both directions, right? It means if it's greater than 10 ounces or less than 10 ounces, it would be. So basically, that's saying that it is not equal to 10 ounces. If you go both directions, that's not equal to. Okay, you're never going to say less than and greater than. You're going to say not equal to. Okay. So basically, if it's not giving me 10 ounces, there's a problem. That makes sense? Well, yeah. It always seems to be at the lower end, not the upper end, you know? That's all null hypothesis and alternate hypothesis is, by the way. That's it. That's the new step. We're going to do a couple more of them so you can get an idea of it, but that's the new step. This is actually 11.1. This is all 11.1 is. State the null hypothesis, state the alternate hypothesis, you're done with 11.1. That's it's these, there's no calculations, no. Okay. There's no calculations in this. This is literally when we get to 11.2, we have all the calculations, but 11.1 is just this. But believe it or not, this is something that confuses people. So, all right. So, Martha Brandon wants to assess candidacy for the forthcoming race for state senate. She is incumbent and wants to raise significant support to retain her seat. How should she formulate an approach to a hypothesis to determine if there's an overwhelming evidence that she will retain her seat? So what is the null hypothesis? How is, yes.
0.51. 51% would be over the majority.
Okay. So your null hypothesis is 50.
Oh, okay.
Your null hypothesis is always equal to. Okay. So your null hypothesis is stating that boundary. So that equals 0.5. Your alternate hypothesis, in this case, we want it to be greater than 0.5. Because that's when she would retain her seat. Okay. So your null hypothesis is always equals. That's the hard part a lot of times, is that when people think about it, it's like, oh, well, that's what I'm trying to, like, it's always equals. The alternate hypothesis is always going to tell you the direction we're looking at. Yes.
She wants to get the majority, right?
Yeah.
So why wouldn't it be 51%?
Because it could be 50.1%.
Oh, okay.
or it could be 50 and one extra vote. Like that's all you really need. So the borderline is the 50%. And that's what we're looking at in terms of our null hypothesis, is that border. Because notice that my alternate hypothesis is never greater than or equal to, or less than or equal to. It's always, and it's not equal to. It's always the opposite in looking at the direction. So that's my alternate hypothesis. So I said it can get a little tricky, and that's where a lot of make mistakes is they look at the null hypothesis as what I'm trying to prove, and it's not. That's the border. Huh? There is no 50 in the problem. How do they win? They have to get more than 50% of the vote, right?
That's like in the election.
Yeah.
Oh,
This is part of the problem. You have to have some kind of concept of what the problem's asking. Because, and we know Hawks likes to do this, sometimes they're not giving you those numbers. Most times, if they don't give you a number, it's going to be an easy thing. And most times it's going to be a 50-50 split.
oh my God.
I know.
Yeah, like Googling how many cards are in debt. Literally, I had to look at a picture.
I want another one.
13 times 4. You know, there's 13 cards.
I did not know.
I know. That's the thing. That's the thing. It's like you have to, like this is that whole concept of like the SATs and stuff like that, or being culturally sensitive to things. Like there's certain things that people just don't know because they're not involved in that. Like there'd be a problem about rowing, and like if you've never been on a boat, you have no clue what rowing or crewing is. It's like, so you don't put those type of questions. It's like there's certain things that we assume people would know when you create problems, and that's not always true. That's why when I wrote the book, we actually put what face cards were. Like we actually put how many of each things are there because people don't know those things. But we kind of need to use the cards because those are one of those things that really comes up quite a bit. All right, let's look at this one. I didn't want to, oh, I duplicated it. I didn't. Hold on. I hit the wrong button. Okay, that's what it was. All right, null hypothesis and alternate hypothesis. One second. I'll let you say it. Okay, what's my null hypothesis? Yes. So equals 240. Technically, actually, this should state, it should state the mean equals 240. That's actually supposed to be how you write it. Yes.
Oh, I was just considering.
What's your null alternate hypothesis?
Is it greater than? Uh-oh.
Oh no, I'm reading it to make sure it's the right direction. Yes. Sorry, I was just reading it to make sure I had the right direction. Yes. Yep.
So for like, these are the alternatives. Like it's always gonna be like greater than or equal to. If
No, it's always going to be greater than, less than, or not equal to. No, no, because you can't be the same as your null hypothesis. And since your null hypothesis always takes the equals, it has to be different than that. So it'll never be greater than or equal to, or less than or equal to. It'll be less than, greater than, or not equal to. That will all make more sense on why when we actually do the calculations in a second. Because if it equals, we're going to be totally screwed up. All right. This is a whole bunch of stuff. It's basically going to be what we're going to talk about in a second. Don't write it all down. It's fine. All right. So let's actually do a problem and actually add in the extra couple steps. So the first thing I want you to do is read the problem and find me my null hypothesis and my alternate hypothesis. All right. What's my null hypothesis? Yeah.
With the 150.
Hold on, I should read this one. Yes. So that is what should happen, right? And then my null hypothesis is going to be what?
The alternative would it be,
Or sorry, my alternate hypothesis. Yeah.
would it be not equal to 150?
Why?
Because they're not looking for anything. They're looking for above or below. It doesn't matter which one they are. They're just looking for.
Yeah. So the key word here is different from. Okay. You would assume they would want higher. Don't. You have to look at exactly what it says. So in this case, it says different from, which means they're just wanting to be different. It means it could be lower or higher. All right, either direction. Okay. There is more information here because we're going to do some calculations with the net rate. Yes. You still need to look at not equal to, because the question was, is it different? Okay, and that's actually can be confusing with that, is that because when we actually are going to do the calculation in a few minutes, you'll see where that actually changes or how we're looking at it. So you don't want to look at your answer and go, okay, which way am I going to assume to go? So when you're stating your null hypothesis and your alternate hypothesis, you're not looking at your results, you're looking at what you're talking about. And then we're going to do the test to determine if those results are in that area. Okay. All right. So are we good with null hypothesis and alternate hypothesis, kind of? But we're going to do more because we're going to do a bunch of calculations. Now, here's the big key when we're looking at these. So if it's not equal to, it's that two tails. If it is greater than or less than, it is that one tail, which we've already talked about. Okay. All right. Next step. Just like we did in chapter 10. we now have to go through and do our calculations to find our the z-score. Okay. Now, what pieces of information do I need to find my z-score? I need the mean, standard deviation. So I need my mean. I need my standard deviation. I need my x value. One more. Sample size. I need my n. So that's the sample size. So my mean in this case was 150. My standard deviation was 15. This is where that 154 comes in. That's my x. That's what I got. And my sample size was 100. Okay. So your mean should equal your null hypothesis. Okay. The x value, that's what that's whatever your experiment was, or your sample data was. Okay. All right. So what's my z-score? Yes, good. So we did, what is that? 154 minus 150 over 15 divided by the square root of 100. Oh, wrong calculator. That's what I want. So remember, Desmos, type it in. You could just set this formula up because you're gonna use this a bunch for chapter 11. So you could just set the formula up and just type the numbers in if you want. So we got 2.6, and since it's a z-score, we round to 2 places, so it's 2.67. Okay. Nothing different than what we did in chapter 10, right? We found the z-score, needed to use that information. Okay. Now, this is the next piece we look at. So right now, my score that I got is like right there, right? Oh, I did switch. So my score is like right about there, right? Okay. So the next thing we need to look at is the number they gave me. They said the level of the test is to be set at 0.05. So now we go to our table. And remember, the z's are on the bottom, right? Yeah. So what you're going to look at is look at the very top of the t-table. Hold on, I'm going to pull it up. So look at the top of the t-table. Are we looking at one tail or two tail here? Two tail. And we're looking at 0.05, right? And we go all the way to the bottom, and there's my z-score. 1.96. Okay? So look at the top. It's two tails, 0.05. And then we go all the way to the bottom to find my z-score for that. So 1.960. You're going to see right now. All right. So, are we good with the t-table? Everybody see where I got the 1.960? This is a two-tailed test, right? So it's plus or minus that number. Okay, so there's my 1.96 and the negative 1.96. If we are in that area, so in the shaded area, this is my reject region. Okay. And in here is known as a fail to reject. So if we are in that shaded area, we reject the null hypothesis. Okay. If we are not in that shaded area, if we're in the middle, we fail to reject the null hypothesis. Notice I did not say accept it. It is reject or fail to reject. Those are the only two options. Okay? That's where the 2.67 comes in. Where's the 2.67? And the reject region. So in this case, to go back, actually, let me duplicate. So in this case, we're going to reject the null hypothesis. Yes.
So is it always within that 95% range?
No, it's always in whatever range they tell you.
Oh, now I see. Well, yeah, now I.
They have to tell you that piece of information.
Okay, now it makes sense.
Okay. Now, why we're looking at the directions matters. If you look at your t-table, and we were only looking at one-tailed, right? That's where the 0.05 is. Look at your z-score for that one. It's different. So depending on the direction you're looking at, your z number will change. In this problem, it wouldn't have made a difference. We were going to reject it no matter which one we had chosen. But in some, it could be really close. And that could make the difference between it. So it's very important that when you're looking at it, you choose what that statement is there for. Yes.
So to figure out whether or not like, you go to reject or you reject it, is it like just that's to draw out the?
Yep. Draw the bell curve and shape. That's honestly the best way to do it. Okay. So yeah, do something very similar to this. Okay. Now, the next piece of this is actually important. So when we reject the null hypothesis, you have to state it in terms of what their question is. So we've got the reject. That means that the sophomores at Lincoln High School are reading at a different level than the national average. Okay. So we can reject that. That's what the rejection means, is that we now can state that they are reading at a different level. Notice I did not say at a higher level. Okay. You always have to go back to what your alternate hypothesis was in that respect. So in this case, we're going to say that the Lincoln High sophomore students are reading at a different level from the mean because we rejected our null hypothesis. Okay. If we fail to reject, we would say we cannot determine if the Lincoln High students are reading at a different level. The data doesn't support that. We're not saying they don't. We just say we can't determine that. Okay, because you can never basically accept it is the key piece. Because we're still testing on that range, right? We're still saying 95 or whatever else confidence levels in there. So we don't have an absolute fact that it's going to be there. We just know that it's probably not in that situation. Okay. All right. Questions? Okay. Find me my null hypothesis and my alternate hypothesis. All right. What's my null hypothesis? Yeah. Yes, equals 16,000. What's my alternate hypothesis? Greater than 16,000 because it says increases. Huh?
So I thought greater than was the other way.
Oh no, it's always eating the bigger number. So since the mean would be greater than that, so the alligator eats the mean. Depending on which generation, depends on what the teacher taught you. It used to be like mine, it was Pac-Man. Now it's an alligator. Yeah, so it just depends. I grew up in a generation we played arcade games with Pac-Man and I was Eat the Ghosts. All right. Okay, so we've got those two pieces of information, right? The next two things we need to do, you can do them in any order you want. We need to find our z-score and we need to find our rejection region. Those are the next two things we need to find. Okay? Either way, doesn't make a difference. I gotta get my bell curve first because I keep forgetting to grab that. All right. So let's do our little rejection region for this one first. So what's my level? 0.01. And are we doing a one-tailed or a two-tailed test? One-tailed because it's greater than. Okay, this is a one-tailed. Not two-tailed is the not equal to. One-tailed is greater than or less than. And depending on which direction, depends on if it's going to be positive or negative that you're going to use, is what the piece is going to be there. So we're looking at the 0.01 on the one-tailed test. 2.326. And now since it's greater than, that's going to be the positive version of that. Yes.
1,000.
No, we're using this. We have the standard deviation.
Oh.
Sorry, I actually, like, in my next question, we're going to actually ask that. I totally forgot to ask, do we have the z-score or not? We have the z-score in this case. Or we have the standard deviation in this case. So we're using z. But good thought, because I didn't actually ask that question, which I was going to. So the one-tailed 1% is going to be 2.326. So my shading is just over here. Okay. Now we need to find my z-score. So we have, what's our, oh, did I not? Wait, it doesn't give you the number of this. Hold on. I hate problems that don't give you all the information in the original statement. And of course, Fox scripts me out. Okay, so the x is going to be, all right. So we got our mean was 16,000. Our standard deviation is 2,500. Our x is 16,200. And our n is what? 1,000. Okay, so now we can find my z. It was part of the problem that's like 2 or 3 extra steps after that point, so it was not written in that stage. All right, so what's my z in this case? Yeah.
5,
Yes. So remember, z is always 2 decimal places when we look at, because we have to look at the table, so we just always go into 2 places. So 2.53. All right. So is it in my rejection region or not? Yes. So 2.53 is over here. So we reject. Remember I said that 1-tail, 2-tail can make a difference? If we had messed that up and did a 2-tailed, my z would have been 2.576. And then I would have failed to reject. Okay. So that's why it's important to make sure you get your 1-tailed and 2-tailed correct, because it can make a difference. So this one, I am rejecting it, which means that there has been an increase in the lifespan of the chip. All right. So you brought up a good point. When you're looking at this, remember we had the question between the z table, z and a t, right? What's the difference between the two?
I don't want the sample, Even's population.
Right. So it's the difference between the sample standard deviation and the population standard deviation. If they give you the population standard deviation, then that's what you're using. That's the Z. If they give you the sample, then you have to use your T. So in these two problems, they gave me the population standard deviation. So therefore, I was able to use my Z. This one, they give me the sample standard deviation. Okay, it says the sample is 20 employees, find the mean time is 29, but the sample standard deviation or standard deviation is 8 minutes. So we're going to use the T on this one. Remember, the calculations are the same. We just need to look at the table to find the T. So let's get our little bell curve here. All right. Null hypothesis and alternate hypothesis. Yes. Difference. Yep, that'd be not equal to.
It would be the 29.
The 29 is my sample. That's X. So researchers designed, she believes the average time will take was 35 minutes. So that's my mean. When we do the sample, that's going to be the X. So 29 in this case will be my X. All right, so my mean is 35. My standard deviation in this case is 8. My X value is 29, and my sample size is 20. Okay? All right. So let's look at my T table and get my rejection reason. So first off, what is my significance level? 0.05. Are we doing a one-tailed or a two-tailed? Two-tailed. So we're looking at two tails, 0.05. And then what's my degrees of freedom for this one? Remember, degrees of freedom is always one less than the n. So in this case, it's 19. So I'm going to look at the 19, and we're going to go over to the 0.05 on the two tails. It says right here that conduct the test at the 0.05 level. And we know it's two-tailed because it's not equal to. So 2.093. So here and there. And now we find my T. And remember, the calculation is basically the same as the Z in this situation. So. What's my standard deviation? 8. The sample size is 20. So what'd you get for your T? I swear they're not all going to be reject. What's the T in this case?
negative 3.3 times 4.
Yep. So that's way over here. So we reject. So we can state that the amount of time to take the test does differ from the 35 minutes. Yes.
So in the real world, how often do you reject and fail to reject?
It varies. A lot of times it depends on your data. So it just happens to be the problems they gave us we're rejecting it because it's like those were those examples. I picked a couple random ones after this point. We'll see if those come up to be it because I didn't do them to decide which way it was going to go. But it could be either way. So a lot of times it depends on what your data is. A lot of times it depends on what your hypothesis is. Right. So because we're trying to determine if the sample that I got basically shows that what I believe is wrong or not. And in most situations, you want to fail to reject because you'd want that your hypothesis to be correct. Like if that's what you believe to be true, that's what you kind of want to be true. So yeah.
What's the key word that lets you know that it's a sample information? Or is it just the inference?
So in this case, they actually gave you the S equals. And S is sample where the squiggly O is the population. But this one also, it's because they actually talk about this random samples and then they give you that in that same sentence. So that kind of gives you that clue. Where we were looking at this one, it says current usable life 60,000 with the standard deviation of 2,500. They give you all that information before they talk about the sample. So that way that would be population. So sometimes they will say sample, sometimes they'll say population, but sometimes it's you have to figure out where that sentence is in relation to the other information. So. All right. Do this one. Oh, you want? I can hold on. I'll make it here.
Do we have to solve like the normal equation and then answer ABC?
Actually, ABCD is all basically is all the questions. Yeah. What's the population? So basically, if you go through and answer the question, you're going to answer all those questions anyway. So you don't necessarily need to worry about A and B. Like you don't need to necessarily worry about those as much. Those come into what you're stating at the final answer. Your significance level is 0.01 because I'm about to erase that part of that question. What did you get for your Z?
13.36.
Oh,
I'm looking at it, I'm thinking, I'm like, I must have done something wrong here.
That's what I just.
2,400, 25.
Yeah.
No, it's a really big number. 13.37. So the severity of the storm caused significantly more damage than the hypothesis was. So we reject. Okay. Make sense? Want to do one more? You got one more. Yeah, let's do this one. All right.
Office is gonna give us a significant.
Yeah. They give it to you in this. It's just in the other part of the, it's like in one of the steps. So it was in step C, and I was going to erase it, so I figured I'd rewrite it in there. It's, it went off. That's what I said. It's going to. There you go. I'm coming back. let's do. All right, what's my alternate my null hypothesis? Yeah, let's go with that one. Yes. What's my alternate hypothesis? Yes. Because they're looking at does not affect, so either direction would affect it. Awesome. Okay. All right. What's the mean is 42.5. What's my standard deviation? Is it population or sample? Population. My X is 45.75 and my N is 12. Good. All right. So one-tailed or two-tailed? Two-tailed, we're doing a significance level of 0.05 and we're doing the Z. So 1.96. That right? So we're there and there. So now let's find my Z. What was the Z? What was it? 2.96? Everybody agree? So that's over here. So you reject. I swear they're not all going to be rejects. So don't assume that. Okay. All right. Any questions? So that's what I was saying. It's in essence the same we were doing with the confidence interval. The confidence interval is going to be the negative 1.96 and the 1.96. It'd be between those two. That's the only difference. Okay. All right. I will see you on Wednesday. You too.